Hi everyone, this is Amy from the Helms Academy, and today we're talking about our Math Roundtable recap from August 3rd, 2020. So whether you missed Math Roundtable that day or you just want to review and catch up, come along. So we're going to go over again our steps to solving a word problem. The first thing I encourage you to do is highlight or underline or at least identify what the important information is. And this helps to take something from a bigger problem into a much smaller problem because we can identify the key parts rather than being distracted or overwhelmed by the other parts. Then we need to determine which operations are needed, and then we can write out our problem using those numbers and operations. So are we adding, subtracting, dividing, multiplying, and what numbers do we need in that process? And our final step is to solve. So today we're going to be looking at some algebra. Starting with word problem 1, it says, if 10x plus 2 equals 7, what is the value of 2x? You'll see we have 5 options here. So the first thing that we need to do is take our equation. So what I see here are 2 parts. I have an equation, the 10x plus 2 equals 7, and I have the final thing they want me to find out, which is what is 2x. Now, the only way I can know those parts is to solve first the equation to figure out what the value of x is, so that I can then use it to get my solution of what 2x is. So let's solve the equation first. 10x plus 2 equals 7. And to get x by itself, the first thing I'll do is subtract 2 from both sides. Remember, whatever you do on one side of an equal sign, you have to do it on the other side also. It's like having 2 children that get jealous if you give one the popsicle and not the other one, right? So make sure you do the same thing on both sides. So now we have the plus 2 and the minus 2, and they cancel each other out. So I'm going to bring down the 10x, and I'm going to do 7 minus 2. Which is 5. So 10x equals 5. So to get x by itself, right now these numbers are multiplied together, and I need to do the opposite. I need to divide. So if I divide by 10, that'll get x by itself, and I'll also do 5 divided by 10, which is 0.5. Now, if I stop here, I'm in trouble because I could easily see letter D, 0.5, and I could get mixed up and say that must be the right answer. But what it's asking me is, what is the value of 2x? So not just x by itself, but 2x. Well, we know that 2 halves equal 1 whole. So 2 times 0.5 is 1. Our word problem 2 says, a number n is multiplied by 3. The result is the same as when n is divided by 3. So what is the value of n? Well, I see a couple things I need to pull out here. First, I see n multiplied by 3. So I would write that out as 3n. And I see n divided by 3. So n with like a slash, or you could put an n over 3. But we want to show that divided by 3. Now, what I think is interesting here is they give us some complicated language. They say the result is the same. Now, when I look at that, I say, okay, if the result of n multiplied by 3 and n divided by 3 is the same, what I could do is I could put an equal sign between them. So that's what I'll do. I'm going to create this equation. Now, this is going to help me to solve the problem. And I'm going to do a few things first. I would encourage you to look through your options, right? I see a -3 and a +3, a -1 and a +1, and I see a 0. So with these options, it's going to give us a little bit clearer idea of what we're looking for and what might be a good option here. Now, right away, I'm going to look at a few things. I say, 3 times 3 and 3 divided by 3 are going to get very different answers, right? If 3 times 3 is 9, or 3 times -3 is 9, 3 or -3 divided by 3 is either 1 or -1. So A and B, I'm just automatically going to say no. Those are not going to work. So the others that I'm left with are -1 and 1 or 0. Well, if I take, let's say, 1 or -1, well, 3 times 1 or 1 divided by 3, or even if we did that with a -1, we get very different answers. 3 times 1 would be 3, 1 divided by 3 is 1/3. So the ones are not working. So let me try the 0. If I do 3 times 0, which is 0, and if I do 0 and divided by 3, which is 0, I get the same on both sides. So the only possible answer we have then is 0. For word problem 3, it says, which of the following equations satisfies the 5 sets of numbers shown in the table above? So you can see our table up above that has a y and an x, and it gives the values that go together. So you'll always want to think of the values as when x equals -2, y must equal -4. When y equals 31, x must equal 3. When x equals 0, y must equal 4. And that will help us to better solve the problems that we have at hand. So when I look at this, I'm immediately going to go to the easiest ones first, because these are some complicated equations. I look at A, B, and E, and I think, wow, those have a lot of steps to them with the exponents and the multiple parts, but C and D are pretty easy. So the easiest way for me to figure out how to solve this is to first look and see if there are any easy patterns here. Like if I just multiply 6x, so if I multiplied all the numbers in the x column by 6, I should get the number in the y column. So I can try that right away and say 6 times -2 should equal -4, but it doesn't. It doesn't. 6 times -2 would be -12. So C is automatically out. It doesn't work for even one of those sets of numbers. So let's look at the second one. If I have the right answer for D there, which is just 2 times the x value should equal the y value. Well, let's see, I could do 2 times -2, and that should get me -4, which it does. Okay, so it works for that one. So let's keep going. 2 times 3, that second set there, and I should get 31. Well, no, 2 times 3 is only 6. So right away, C and D, the simplest ones, they're not going to work. So I was able to do some mental math for that, right? I didn't have to write everything down. And it's okay if you do want to write things down too, but if you're looking for ways to save time, it might be easier to get rid of some of those answers that are a little easier. Or if they work and they work for all the different pairs, that could be an easy way to solve the problem quickly. So we've got it down to 3, and what I'd encourage you to do is if you have a really good guess about one of them and one of them looks more promising than another, or if you know for sure one's not good and you want to knock it out, that's what I'd encourage you to go for. In my case, these all look pretty similar in that they have different aspects to them. I would say because the numbers at the top are so different from each other, for example, I see a 0 and a 4, which are only 4 digits apart, the -2 and -4, which are only 2 digits apart. But then we have things like 31 and 3 and 68 and 4. I can't see a very clear pattern here. And that says to me that most likely there are exponents involved, because exponents can really change our outcomes of a problem. So I am looking primarily at A and B. So I'm going to start with A just to look it over. So what I'll do is I'm going to plug an x value in from our chart and see if it gets me the y value. So our initial is y equals x to the third plus 4. So I'm going to do y equals -2, which is my first x value on the chart, to the third plus 4. Now, I need you to think about -2 to the third as -2 times -2 times -2. So I've rewritten it there, as you'll see on the second line, plus 4. So I'm going to solve my multiplication first. Think about it this way, -2 times -2. 2 negatives multiplied together make a positive, so we would have +4. +4 times -2 is -8. Now, if I add a +4 to a -8, I'm going to get -4. So there we go. If I plug in that -2x value, I come out with y equals -4, which fits with our chart. But you might remember before, letter D actually worked that way as well. And so I just want to plug in another value to see if this actually works with more than one. So let's try the number 3. So y equals 3 to the third plus 4. Or we could say 3 times 3 times 30 plus 4. Well, 3 times 3 is 9, times 3 is 27. And when we add 4 to that, we get 31. So y equals 31, and that matches with our pairs. The next one I could even do in my head, I see that 0 and a 4, and I know 0 to the third is still going to equal 0. right? 0 to any exponent is going to equal 0. Plus 4 would be 4. So that would give me my x and y values of 0 and 4. So I know that letter A is going to be the best option. Now, if I had had them in a different order, had chosen to look at a different one first, I could just try the different ones and say, you know, B did not work, and so I'm going to try E or A next, and I can go through them that way. But again, the more that you can use your understanding of math and your ideas about which would be the best options or which would not be the best options, it's going to help you save some time and some energy. So our last word problem for today is, what is the greatest integer value of y for which 5y minus 20 is less than 0? So I'm looking for a couple things. First, I'm looking for the greatest integer, and that's for y. And I'm looking for something that is less than 0 when I plug it into my 5y minus 20. So right away, I'm going to try through some of the answers that they gave me here. So 5y minus 20 is my base. So if I do 2 gets plugged in for y there, 5 times 2 minus 20 is 10 minus 20, or negative 10. Now, is negative 10 less than 0? It sure is, right? Everything negative is under 0. So 2 works, right? It works to be less than 0, but here's the trick. We want the greatest integer here. So we need to do a little bit more work to see which one is the greatest. Now our next answer is 4. So let's plug that in. 5 times 4 is 20, minus 20 is 0. Well, 0 is equal to 0, but it's not less than. So letter B, 4, is not going to work. And in fact, I'm going to go ahead and get rid of letter E, 5 as well, because we already know that 4 is too big, so 5 is definitely going to be too big. Now let's try our other two. If we do 1, we'd have 5 times 1 minus 20, which would equal negative 15. That is less than 0, and it does work. But already I know, okay, 2 works, and it's bigger than 1, so I need to be aware of that if we're looking for the greatest integer, the biggest value. And for letter D, I have the number 3, so if we did 5 times 3, that would be 15, minus 20 equals negative 5. So that is also less than 0, and now I just need to decide which one of these is the greatest integer of the 3 that would work, which means which one is the biggest number? Well, of 1, 2, and 3, 3 is the biggest number. So that's the one I would choose for the correct answer. Thank you so much for solving these problems with me and joining me for this Math Roundtable recap. I hope that you'll subscribe to our YouTube channel so that you get all the latest updates about when we post a new video. And you can also check us out on Instagram and Facebook for some inspiration and practice quizzes. And you can also check us out at helmsacademy.org.